This is the Chapter 4 practice exam number 3. A 3 kilogram box sits on a frictionless table. It is connected by a light rope that goes over a frictionless massless pulley that then attaches to a hanging 11 kilogram box. My picture here is kind of bad, but I want to draw free body diagrams and find the tension in the rope and the acceleration of both boxes. Alrighty. Okay, so first we need free body diagrams. So I've got the 3 kilogram box. I'm going to need axes for this, and just looking at this, since there's no friction anywhere, this thing is going to tend to move to the right. I'm going to go ahead and make that the positive direction. Okay, for the 11 kilogram box, it doesn't really matter what we do in the x direction because nothing's happening there, but since this thing is going to tend to move down, basically, when the 3 kilogram box moves to the right, we solve that positive, then the 11 kilogram box moving down would accompany that. That would have to be positive as well. So I'm going to have to make this positive y for down. Okay. Forces. So I've got normal force, and I've got gravity. Here, this would be 3 times 9.8, or is that 20 something? I don't know. It doesn't even matter. We're not going to use it because these two are going to cancel out, so I don't even care. However, I do have tension here. I do care about that. This one's going to be held up by tension and pulled down by gravity, which would be 11 times 9.8, which is 107.8. I'm not rounding that yet because it's not a final answer, so don't round yet. Okay, now we want tension and acceleration. Basically, we're going to get both by solving a system of equations. Namely, let's see, F net equals ma. Okay, for this one, the net force in the x direction is T, and that's going to equal mass. This mass is 3 times acceleration, and that's it. For the other object, F net equals ma. We've got in the positive direction, we've got 107.8 newtons, which I'm going to leave the newtons out, minus T equals, here mass is 11, so 11a. Okay, I'm going to go ahead and put this one in there. And now I have 107.8 newtons minus 3a equals 11a. Add 3a to both sides, and we get 107.8 equals 14a. Therefore, acceleration must be 7.7 meters per second squared. That's one answer. Put a box around it so I can find it easier later. Okay, now I take that A and put it back up in here, and I get tension is 3 times 7.7 meters per second squared, and therefore tension is 23.1 newtons. Put a box around it so I can find it easier. Okay. Okay, now for points. This problem specifically asked you to draw the free body diagrams. Okay, when that happens on the AP test, in general, the way that it is graded is they will give you a point for each force correctly on the free body diagram, and they will take away points if you have like extraneous forces. So here's how it works for this particular one. See, I'm going to give you a point for that, and a point for that, and a point for that. And then I'm also going to give you a point for having the directions match. Well, okay, now how about a point for both of these together, like that they're there. The reason I'm not giving you one for each is because I need the other point somewhere else. Namely, I'm going to give you a point for writing this down and a point for writing this down. Notice that you get it twice because you're using it in 2 different places. This is not the same place. You get a point for the answer in tension and the units, and a point for the answer in acceleration and the units. Notice, even if you couldn't get like, you got to here, I have no idea what is going on. You would get 6 out of 10 points. If you got here and you're like, I don't know what to do. I don't know what's going on, but I know they want tension, and the units of tension are in newtons. You could just write this. You'd be like, tension is like something in newtons. Heck, there's another point. Same thing with acceleration. Okay, so remember, point farming, we are going to write down anything that we know at all, even if we can't do anything with it because we don't know what we're doing. Okay, so in all we got 10 points here, I think. 4, 5, 6, 7, 8, 9, 10. Yep, that's it. Alright,